Hey, my name is Chris. I'm going to show you some software I made. Over the years, I've done work as a translator from Thai to English. Translation can be very time-consuming, and part of that is you have to do a lot of research into domain-specific terminology, but also because sometimes when you do a literal translation of a phrase, it can be very awkward in English, and so you have to think of like a creative way to rephrase it. If you find a way to reference translations you've already done, it can actually save you a lot of time. So what happens is translators will build up this database of reference material. So it's very tedious to search through all those files manually. So to automate this, they've invented something called cat tools. Basically what they do is as you translate a document, they remind you of prior translations you've done, similar to the one you're working on. Probably 88% of translators now use them. And for some fields like legal translation or patents, where there's a lot of repetitive boilerplate language, they're absolutely essential because they can dramatically improve your translation speed. Even though these tools are really useful, they just don't work very well with the language that I translate in. So it kind of bothered me, so at some point I was like, I'm just going to make my own.
And ta-da, here it is. So I can't show you everything, but I'm going to show you the main idea. So first I'm going to go up here to the home page. Right here is a list of documents that I've translated before, but right now we're going to start a new one. I'm going to click on this thing called demo file. It's obviously a file I just made for the demo, and then it switches over here to the translation pane. I made this demo file in English just to make it easier for you to see what's happening. On the left here is the source document. On the right is where you can write your translation, like this. Translation for segment 1. Okay. I can click on here and I can edit this. That's pretty important because I deal with a lot of OCR files, OCR PDFs, which have a lot of typos. I can merge segments. Okay. I can then split them. But first I'm just going to undo all of that. Okay. When you're done writing out all the translations, then you can go up here and click Export, and it writes out the translations to a text file. Okay, none of that was very interesting, so let me show you what is. Okay, so I've written out a translation for these first two segments. I'm going to select both of them and go up here and click the button Commit. By the way, all these buttons here and the whole UI I designed myself. I kind of drew it out on paper first and then finished the design using Photoshop and Illustrator. Okay, so you can see when I hit Commit, this changed the status column to blue, and something changed. So when I click on this third segment here, you can see down below, actually it's now showing those first two segments. And that's in a nutshell what this program does. It reminds us of previously committed translations that have some commonality with what we're currently translating. Right here in green, this actually indicates there's a common substring between this segment and the one up here. You can see this one's a bit shorter. So if over here, I just happen to know that this second segment is 19 characters long. So if I change this min match length to 20, what it's going to do, boop, that made that second segment disappear because we raised the threshold of what segments we want to see. These segments down below that it's showing matches for aren't just within this one document. It's for any files that you have in your corpus, things that you either translated yourself or you downloaded offline. Let's take a look at a real file. You can see down here I set the min match length to 5, and that actually creates a lot of matches. There's over nearly 3,000 segments.
So you can see with so many matches, the ranking algorithm is pretty important, but more on that later. First, let me show you how search works. I use something called an inverted index, which comes from the field of information retrieval, which covers things like search engines. In retrospect, I almost certainly didn't need to do anything this fancy. I could have just, did Unix grep on like every possible combination of words, but it was kind of fun to learn how inverted indices work. Okay, so what you do is for every document, you break it up into chunks. The individual words, overlapping groups of words, in which case they're called shingles or n-grams, or they could be overlapping groups of characters. Then you take these terms and you put them into a dictionary or a hash map, and you associate each term with a list of the documents that contain it. And the whole list is called a postings list. So I did use an inverted index. I made a few modifications though. So instead of using positional indices, what I did was I just used the inverted index to find a segment. And since the segments aren't very long, then I just took all those candidate segments
and then did some dynamic programming just to find common substrings. Rather than parsing words, I simply made a sequence of characters. The reason I did that is that in Thai, read the README. Okay, let's say we find several segments in our corpus where there are common substrings. Now we could rank them by the total common substrings. We could rank it by whichever one has the longest individual common substring. Either way, it's problematic because these first two segments are really just matching common words that presumably the translator already knows, and instead they want to see the third one, which has an abbreviation, which might be time-consuming to research again. So it would be tempting to use a term frequency list. Basically, common substrings with more rare words would get prioritized. This is a really common technique in IR applications, but I actually found another approach that I feel like works better with this use case. It's based on two principles. Number one, we want to see longer matches. Let's say we have some common substring in our corpus, and then we have another one that's in the same area. I, as a translator, would really prefer to see the green one. And that's because there's no computational way to really determine which one is the better translation. So all things being equal, I would rather see the match with half of my sentence already translated for me than just a few words. Number two, I want to quickly see matches for every part of the source text. So maybe the beginning has a gazillion matches, but the end only has one. I don't want to have to scroll through all the matches for the green part. So let's say we have this sentence that we're translating. Then somewhere in our corpus, we have a segment that has some substring in common with this. I didn't write out the whole segment, I just put ... here. So we could actually arrange all our common substrings in the corpus into a directed acyclic graph. And so they're ranked like this. So if somewhere in the corpus there's a match for United Nations, well, that would appear below this thing because it's a longer match for this interval. What we can do is then traverse it, going from top left to right. And what that does is it allows the user to quickly see these longer portions first, while at the same time seeing every single part of the source segment that has a match. And in practice, I found this worked really well. What would happen is in our source segment, sure, okay, yeah, you would see these matches match in the corp and different. But within a few segments, you would also then see a match for this as well. Apparently doing this is equivalent to what's called a topological sort of a directed acyclic graph. I guess that's a fancy word for it, but it's not that complicated.